before we start today's lesson, let's do some review for tomorrow's quiz. Tomorrow's quiz is 50 points. You're going to be doing quite a bit of graphing now. So a lot of the things that you're graphing, the order doesn't matter, but sometimes it does matter, eh? Like on this one. I already told you this one is on the quiz. Remember we talked about this in class? You have to do it on the homework. You're going to have to do it tomorrow. Now every year I correct this problem and it's just bad. So this year, why don't we discuss it the day before and then everybody can get it right. So there's two ways you can think about this. Either this or this. Okay, so this one, there's two things going on. You can shift, it's going to be a shift to the left, and then there's a reflection over the y-axis, but which one do you do first? Because if you do it in the wrong order, that's when you get the fatal error. So what do you do first? Come on, you guys did the homework, right? Well, shift first or reflect? Reflect. No, if you reflect first, that's this, right? Reflect over the y-axis. If you want to shift the graph 1 to the left, you would substitute x plus 1 for x. Is that the same thing as that? No, so that's why it's wrong. Don't guess, figure it out. Okay? So, if you shift the graph 1 to the left, isn't that this? If you plug in negative x for x, it's going to reflect it over the y-axis. So if I plug in negative x for x, is that what I want? Yes. So you shift the graph 1 to the left first, and then reflect it over the y-axis. Don't guess. So reflect and then shift. So no, that's wrong. Shift and reflect, I just said it then. What about this way, if you think about it this way? There's two things going on. This reflects it over the y. This shifts it 1 to the right. But which one do you do first? Well, like if you don't know, figure it out. Okay, I heard reflect. If you reflect it over the y-axis, isn't that? Now, how do you shift the graph 1 to the right? You substitute x minus 1 for x. So if I substitute x minus 1 for x, is that what I want? Yes, so that's what you do. So this one you reflect first, and then you shift. But just remember, if you do it this way, this one you're shifting it 1 left, this one you're shifting it 1 right. So I don't know how you're gonna, I hope you guys don't just memorize it, because I'm telling you, I'm gonna keep giving you this until we finish the last of our base graphs, which is for a while. Okay, here's another one. This was a candidate on the quiz, but it didn't make the cut. How would you graph this? Oh, I forget it already. I think it was this. No, I think it was this. So it doesn't matter what graph I give you. I can give you any graph. Just do what you're supposed to do to the graph. So there's two things going on here. This one shifts it 2 to the right, correct? And then what about that? Now notice it's not over the whole thing now. So there's two things going on. You got this, and then you got this. Which one do you do first? And of course, if you don't do the correct thing, that would be a fatal error too, right? There's only two things, just like over here. I remember last year on the quiz, people are reflecting it over the x-axis. What is the meaning of that? There's no x-axis, is there? It's the y-axis. Yeah, what about this? Which one do you do first? Do I do this one, or the A or B? So should I go A then B, or should I go B then A? A first. Oh, see, now you guys are getting the hang of it. You're right. You do A first, And then if you substitute x minus 2 for x right there, don't you get this? So you would do this first. Okay, so for example, what if the graph, I don't know what the graph looks like. What if the graph looked like this? Yeah, just do something like that. Okay, so what does this do to the graph? You erase everything to the left of the y-axis, and you keep and reflect the remaining portion about the y, right? You did it on the homework. And then what does this do to the graph? You shifted 2 to the right. So I don't know what 2 is, but if you shifted it 2 to the right, it might look something like that, yeah? So yeah, make sure you know all your graph transformations, and then there's only going to be one where the order is important. The others, it really doesn't matter which one you do first. And make sure you read the problem now. And if you weren't here earlier, there may be more than one word problem. Because you guys said I gave you guys 3. Okay, so if there is more than one, well, it could be 2 or it could be 3, maybe, I don't know. Actually, I know, but I'm not going to tell you. So look, if you guys know how to do all 3 of those word problems, then you got it covered, right? Which means you got to know your formulas for the areas and surface areas of geometric shapes, right? And there was also a question on the homework. Yeah, I kind of labeled it wrong. Okay, if there's ever a question about what to do on the homework, you just do the next one. It's just the next one in line. And all the others are just additional problems for practice. That's the way it's going to work, okay? So I guess the next one in line was called the practice test. Okay, so whatever it was, I think I called it function 4 on the thing, but doesn't matter. If you did function 4, fine, just add that in instead. It really doesn't matter to me. The main thing is you learn from the thing. That's the thing. Okay, so today we go on to the next chapter, which is on rational functions. Now, what is a rational function? A rational function is when you have a polynomial over another polynomial. And you guys know what polynomials are, right? We had a whole chapter on that. Oh boy. All right, so let's do some examples. Y equal 2x minus 1 all over x plus 1. We'll start off really simple. Is this a rational function? Yeah, polynomial over polynomial. Remember, polynomial is when you have x to whole number powers. Like linear over linear, quadratic over cubic. Those are all rational functions. Now, last year when your teacher taught you how to graph these, well, I don't know, what did your teacher teach you? Did your teacher teach you the 4-step process? Okay, if you just go through these 4 steps every time, you should be able to come up with a graph. First, plot the x-intercepts, then the y-intercept, then the vertical asymptotes, and then the horizontal asymptote. Now, tonight's homework only has horizontal asymptotes. We're not going to see the slant and other kinds of asymptotes till rational 2. So tonight, you only have to worry about horizontal asymptotes. Okay, so let's go to the graph. Draw the graph freehand now. Don't use graph paper or anything, because you're not going to be allowed to use that in calculus. So x-intercept. How do you find the x-intercept of any graph? Oh boy. You plug in 0 for y, and then you solve for x. So if you have a fraction equals 0, what does that mean? The top is 0, the bottom is 0, or both? Or neither? That's kind of dumb. It's either the top is 0, the bottom 0, or both. The top is 0, because if the bottom is 0, it's undefined, right? So just look at the numerator. What makes the numerator 0? 1/2. 1/2 is the x-intercept. How do you find the y-intercept? You plug in 0 for x. What happens when you plug in 0 for x here and here? You get negative 1 over 1. Negative 1. That's easy. Vertical asymptotes. How do you tell when there's a vertical asymptote? When the denominator is 0. Okay, so you look at the denominator. What makes the denominator 0? Negative 1. So what is the vertical asymptote? What's the equation of this? X equals negative 1. Don't just say negative 1, because that doesn't mean anything. X equals negative 1. There's a big difference between x equal negative 1, y equal negative 1, x times y equal negative 1, x plus y. You don't know. That's why you got to label it. Now, horizontal asymptotes. This is the one students forget every year. How can you tell just by looking? It's in the notes. If the degree of the top and the bottom are the same, are they? Then you simply look at the leading coefficients. So 2 over 1. That's the horizontal asymptote. So y equals 2 is the horizontal asymptote. Like that. Why is that, Mr. Park? Well, let me show you. How did your teacher teach you about horizontal asymptotes last year? Just memorize the darn thing. No, how do you, okay, what if you don't know anything? How do you find the horizontal asymptote then? Like, what if you absolutely know nothing? Huh? Plot points. Yeah, but even plotting points is not going to tell you. It might look like it's getting closer to y equal 2, but how do you know it's not 2.1 or 1.9? How do you know it's 2? Okay, let me show you something. When you have a fraction, what does this bar mean? It means divided by. So let's actually divide it. You want to do synthetic division or long division? And believe me, you're gonna do quite a bit of that in this chapter now. So, what? Long division. Okay. Remember, synthetic division is a shortcut for long division, but you guys want long. Not too late. I'm doing it. X plus 1. X goes into 2x how many times? 2. Multiply that times the divisor. 2x plus 2. Subtract. Subtract. Negative 3. So when you divide this by this, you know what you get? You get the quotient plus the remainder over the divisor. I mean, I don't care which way. I'll do long division. Synthetic division is a lot shorter. Here, watch this. 2, negative 1, make the box, negative 1. Drop the 2 down, negative 2, negative 3, finish. See, 2 plus negative 3 over x plus 1. See, synthetic division is a shortcut for long division. Well, whatever. Okay, so, when did your teacher last year tell you, when do these horizontal asymptotes start grabbing the graph? When the graph goes out like this, right? Pterodactyl, right? Pterodactyl. When the graph goes out to the right and it goes out to the left, then it starts getting closer and closer to the horizontal asymptote, right? So, what happens when the graph goes out to the right? X is going to be like really large numbers, right? What about when the graph is going out to the left? X will be really large negative numbers, right? So what happens when you start plugging in really large numbers for X, like 1,000,000, 1,000,000,000, 1,000,000,000, what happens? Really? What is 3 over 1,000,001? It's almost 0. What is 3 over 1,000,000,001? It gets even closer to 0. What is 3 over 1,000,000,001? Even closer to 0. So we say that this goes to 0, and then what's left? 2. That's why you get the horizontal asymptote there. Because as the graph goes out here, the graph will get closer and closer to 2 because this thing here gets closer and closer to 0. That's why it is. Okay, so here we go. But of course, you're not going to do that. I'm just trying to explain why it is. When you actually draw the graph, you just quickly go through these things. Okay, now, this is going to be an easy one. So, you see to the left of this vertical asymptote, and there's a horizontal asymptote here. There's only 2 things the graph can do. It's either going to be up here like this. Here, I'll just show you here. It's either going to be like this or like that. Which one is it? Is it up here or is it down here? Down here? Why would you say down here? Because if it were down here, wouldn't it cross the x-axis? But that's the only time it crossed. This is the x-intercept, right? So there's no x-intercept here, so shouldn't the graph have to be up here then? Unless you're like last year, you know what they told me? They said, oh, just go around the x-axis like this then. Are you crazy? This x-axis goes on forever this way. Plus otherwise that's not a function anymore. Go around the x-axis. Go around your grade then. Okay, now what about to the right of this vertical asymptote? Either the graph is going to be up here or down here. Which one do you think it is? It's down here because you got these 2 points you got to pass through. So the graph is going to be like this. And do you see when the graph goes out to the left and the right, see how it's getting closer to the horizontal asymptote? So horizontal asymptotes don't affect the graph until you go out here. You guys understand? So do not be surprised if the graph crosses a horizontal asymptote now. Because sometimes you're going to have a horizontal asymptote and then the graph goes like this. See how it crosses? Does that bother you? No, it shouldn't bother you. You know why? Because these asymptotes only take effect out here. So actually, if you think about it, there is no horizontal asymptote inside here. It's only out there. But we tend to draw it all the way across. So anyway, whatever. All right, let's look at another one. We just have to keep on looking at examples so we get good. Now, who knows? Maybe the problems I'm doing, they're on your homework, but whatever. How about x minus 1 over x squared plus 1? I bet you that's on the homework. Okay, go through the 4 steps. Now, you don't need to write this down now. Just do it in your head. X-intercept. What am I looking for? When is the top equal to 0? 1. It's very simple. A y-intercept. Plug in 0 for x. Negative 1 over 1, which is negative 1. This is easy. Vertical asymptote. What makes the denominator equal to 0?
Nothing.
Well, no real number, plus or minus I, right? But we don't graph imaginary numbers on the Cartesian plane, right? So there is no vertical asymptote. You'd be surprised every year they go plus or minus 1. Don't do that. If that was a minus sign, yeah, then plus or minus 1, but no. No vertical asymptotes in this graph. What about horizontal? Well, in this problem, see how the degree of the top and the bottom are the same? Then you look at the coefficient. If the degree on the bottom is bigger, then what is it? Okay, so let's pretend you're not looking at your notes where it tells you how to figure it out. Remember, horizontal asymptotes only take effect out here when x is either really large positive or really large negative. What happens when you plug in a really large number like 1,000,000? The top is 1,000,000 minus 1, but the bottom is 1,000,000 squared plus 1. What is that close to? 0, that's right. Or it's easier to just remember, if the degree of the bottom is bigger than the top, then it's y equals 0, which is the x-axis. Okay, so now here we go. Now here are your clues. Actually, rational functions are like easier to graph than regular polynomials because you have more clues. So here's the y-intercept, here's the x-intercept. So we know the graph got to go like this, right? Now I'm coming up to this x-intercept. Do I go through it or do I bounce off? What did we learn in polynomials? When you have an odd power, what? It goes through, even power bounce off. Same thing's going to happen here. Okay, so I'm going to go through. I don't know what to do now, Mr. Park. And then, look, if there is a horizontal asymptote, then when the graph goes out here and here, it better get closer and closer to it. Otherwise, why even have a horizontal asymptote? So again, powers on the top and the bottom are very important. What happens when you have powers on the bottom, like here? See, like this one was odd power on the bottom. See, look, odd power on the top. See how that went through the x-intercept? What about on the bottom? What does the bottom tell you? The vertical asymptote, right? So I'm pretty sure you guys learned this last year. So here's the vertical asymptote. If there's an odd power, what happens?
Down.
Yeah, if it goes up on this side, it goes down on that side. It goes the opposite way. If you had an even power, they would both go the same way. Okay, let's make it a little tougher now. Let's put some even powers on there. Okay, how about x plus 1, x minus 1, x minus 2, x plus 2, and let's put it, give me some even powers, what? 2 and 2. Okay, that sounds good. So go through the 4 steps. X-intercept. What makes the top 0? Negative 1 and 2. Come on, even my dog can do that, right? Y-intercept. Plug in 0 for x. I don't know why, every year students have trouble. Isn't the easiest possible thing plug in 0? We cannot plug in 0. What happens when you plug in 0? You get 1 times negative 2 all over negative 1 times 4. 1/2. Because I'm going to tell you right now, if you get the y-intercept wrong, your graph can be up, it's going to be blown to bits already, because nothing's going to make sense. Okay, vertical asymptote. When the denominator is 0. What makes the denominator 0? 1 and negative 2. So here's x equal negative 2, and here's x equal 1. Asymptotes are always drawn with dotted lines. Dotted lines means it's not part of the graph. It's just there to help you graph. Horizontal asymptote. If the degree of the top and the bottom are the same, which they are, you look at the leading coefficients. Okay, look, if you were to multiply out the top, wouldn't the first term be 1x cubed? Right? If you were to multiply out the bottom, wouldn't the first term be 1x cubed? So if the degree of the top and the bottom are the same, you look at the leading coefficients. 1 over 1. 1. So y equals 1 is the horizontal asymptote. Okay, now look, there's so many clues. There's no way we can not graph this. So is the graph going to be up here or down there? Yeah, it's going to be up here. How come it has to be up there? Because there's no x-intercept here. And none of this going around the x-axis business. So it has to be up there. Now, what about on the other side of this vertical asymptote? Is it up here or down there? Well, this vertical asymptote came from this factor here, even power. So what? What did we just say? Were you here 1 minute ago? If you have an even power, they go the same way. Odd power, they go opposite way. But there's an even power, so it's going to be up here. Okay, now, I'm coming toward this x-intercept. Oh, by the way, look, I'm passing through that horizontal asymptote. Is that bothering you? I told you no! You know, out here only. That should not bother you. Okay, now I'm coming up to this x-intercept. Do I go through it or bounce off it? Well, this x-intercept came from this factor, even power, bounce off. Anyway, think about it. If you don't bounce off it, how the heck you going to get to that point? Right? Because some of you are going, oh, I go through, oh, but then I got to get to that point, so I got to go through again, but there's no x-intercept there. It doesn't make sense. It has to bounce off, right? Okay, and then what? Go back down or go up? Well, there's no x-intercept here. Up. There you go. It goes like that. Oh, so it crosses the horizontal asymptote twice. Does that bother you? Mr. Park, if it bothers me once, it's going to bother me doubly if it goes twice. And then, since it's exploding upward here, what about on the opposite side? This vertical asymptote came from here. Odd power. So what?
Switch side.
So it's if it goes up on this side, it's going to explode down on this side. Now I'm coming up to this x-intercept. What should I do? Go through or bounce off? Well, This x-intercept came from this factor on power. You go through. Anyway, think about it. If you don't go through, like if you bounced off, how is it going to get closer to that horizontal asymptote? I don't know, Mr. Park, I'll find out. I'll figure out a way. No, because then you would have to cross the x-axis again, but there's no x-intercept there. And again, look, as the graph goes out to the left and the right, isn't it getting closer to the horizontal asymptote? Now, is there a way that I can figure out where the graph crosses these horizontal asymptotes? Yes, in fact, it's going to be on the next quiz, which is next. That will be the last quiz of the quarter. When is it? Next Tuesday or Wednesday? Okay, whenever it is, it's Tuesday or Wednesday. I'm going to ask you, where does the graph cross its horizontal asymptote? That's easy, because what's the equation of the horizontal asymptote? Here's the horizontal asymptote. What's the equation of that? You guys just told me like 2 minutes ago. Y equal 1, right? So here's the equation of the graph. Here's the equation of the asymptote. How do you figure out where they intersect? Yeah, it's called substitution. Actually, substitution. So since y equals 1, just substitute it in. 1 equals x plus 1 squared times x minus 2 all over x minus 1 times x plus 2 squared. If you solve this equation, that will tell you the 2 times it crosses the x and the horizontal asymptote. Okay, let's actually do it. How do I solve this equation? Rhymes with Haas multiply. Well, even with the rhyming, it takes a step. Did I take my blood pressure medicine this morning? I hope so. It's my keel over. Okay, so the only way we can solve this is we got to multiply it out. Do we just want to multiply it out the long way, or do we want to use Vietta's formulas? Remember Vietta? Okay, let's just multiply it. Give me the strength. Hey, you're gonna have to do this next week. What you gonna do? Okay, we're gonna multiply it out like mad, like rabid dogs. That's what we're doing here. Okay, so look, take the first term, distribute it. Remember how we showed you how to do it when we did poly? Take the first term, distribute. Take the second term, distribute. So then what does this stand for? X to the third plus 3x squared plus 0x minus 4. I don't care how you do it, just do it correctly, okay? What about this side? Take the first term, distribute. Take the second term, distribute. Add them up and you get x cubed plus 0x squared minus 3x minus 2. Hey, Mr. Park, the x cubes cancel out. So you get 3x squared plus 3x minus 2 equals 0. Did I do that correctly? Does that factor? Is this factorable, or do I have to use quadratic formula? How do you tell if a quadratic is factorable? The discriminant is a perfect square. Is b squared minus 4ac a perfect square? 9 plus 24 is 33. Is 33 a perfect square? No, it doesn't factor, so you gotta use quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac. I already told you what that is. 33. Because if that was a perfect square, then you're gonna get rational roots, which means you could have factored it. All over 2a, and you can't really simplify that. So what are your answers? Negative 3 plus root 33 over 6. These are just the x coordinates now. How do I figure out the y coordinate? So take this and plug it in here.
No.
You can if you want. But wouldn't it be easier to plug it in there? You'd be surprised. Every year I give that problem on the quiz, and there's maniacs plugging it into this one. Why? They both intersect at the same point. It's 1, 1, 1. Think about it. Doesn't the y-coordinate have to be 1 if it's right on the horizontal axis? Then you tell me, why are people plugging it into here? I don't know, it's craziness. It's madness. Okay, anyway, that problem's going to be on the quiz. Well, I don't know why I'm telling you these things, but I do. All right. Okay, we still haven't gotten through it. I'm going to erase now, because we're going to do some more examples. Okay, let me think of one. Shh. Let me concentrate. Y equals, okay, on the bottom. How about x cubed minus 3x plus 2? Huh. Woo! X squared minus 4. Yeah, let me think about that. Yeah, that's good. Okay, here. This is a good problem. Okay, so go through the 4 steps. X-intercept. Okay, first thing, what do you notice about this? It's not factored. We really want, if it were factored, wouldn't it make the problem a lot simpler? So if it's not factored, what you should do is factor it. So I'll do the top. What about the bottom? Synthetic division? Oh, no need. No need to synthetic division. Okay, let me hear it then. Go.
X minus 2. Oh.
This is a cube now. This is a cube. Okay, don't do this now. If anybody does this, I'm going to take a double. In fact, I'm going to take a triple if I say, oh, just make a square here. No, that's really? Because when you go outside, inside, no. Okay, now do we want to do synthetic division? Okay, thank you. Oh boy. 1, 0, negative 3, 2. What number should I put in the box? Factors of 2 or factors of 1?
1.
Okay, 1. 1, negative 2, 0. Hey, you're right. So x minus 1 is a factor. And what's the other factor? What does this stand for? X squared plus x minus 2. Doesn't that factor as x plus 2 times x minus 1? So then this is going to be x minus 1 squared times x plus 2. That's the correct factoring. I don't know what you guys were doing. It's cube. What, do you think we learned synthetic division? Now we just forget about it? Just purge it? We're going to keep using, we're going to use it till, synthetic division, you're going to be doing until your math career is over. Oh yeah, after this year, Mr. Park. Okay, what do you notice? Do you notice anything before we even start? These cancel. What does that mean? What did Mr. Cropsey tell you last year when you cancel stuff?
There's a hole.
There's going to be a what?
A hole.
A hole.
Okay.
What did Mr. Rubash call this thing? Did Mr. Rubash call it a hole? A puka? No, come, who had Mr. Rubash? What do you call a graph and there's like a hole in it? What did Mr. Rubash call the hole? You guys called it something, right? Oh, ghost point. Ghost point? Okay, so what did he call it then? Who had Mr. Rubash again? Okay. Tanaka. Oh, so now it is a hole. But you guys said no, it wasn't a hole. Kimura, what did Mr. Rubash call it?
I don't remember.
Okay, what did you call it then, like in your brain when you're drawing it in your graph? A hole. Oh my goodness. Okay, there's going to be a hole, but that's not the official name now. I know Mr. Cropsey, didn't he give you like the official name of the hole, the puka, the ghost point? It's called? Oh boy, okay, so I'm not ready to tell you yet. So what you do is you cancel it out and then you just graph this. This is what you graph. You don't worry about the whole until later, okay? So just draw this graph. Go through the 4 steps. X-intercept, easy. 2. Y-intercept, plug in 0 for X. What? -2. Now remember, you get your y-intercept wrong, again, your graph is just not going to make sense. Vertical asymptote. X equal 1. Not 1. X equal 1. Horizontal asymptote. If the degree of the bottom is bigger than the top, it's y, no, not 0, y equals 0. You guys want to be laughed out of the dormitories if you go to college? I'm trying to teach you the correct mathematics. You can't just say 0, it's y equals 0, because what does that even, 0, you can't even graph that. It's y equals 0. Okay, so is the graph going to be up here or down there? Down there, because otherwise, come on. How it's going to be up here if you're going to go through the y-intercept? Well, if you drew it wrong up here, yeah, then it would. Yeah. And then what? Ooh, Mr. Park, there's an even power on the bottom. What does that mean? That means it's going to go the same direction, so it's going to be down here. And then what? Go through this x-intercept or bounce off? Go. Odd power. Go through. And then what? Then you get closer to the horizontal asymptote. Box that, that's the answer. No, now you put in the hole. Okay, so the hole occurs when x is -2, right? Because that's what you canceled out. Because if you try and plug in -2 for x, you're going to get 0 in the denominator. That's undefined. So that's why there's a hole there. So, oh, easy, Mr. Park, just do this. Here's -2, just put the hole there. Okay, but you know when you graph, you have to label these holes. And by the way, it's not called a hole. You know what this is called? It's called a removable discontinuity. Does that sound familiar at all? Removable discontinuity. How come some people go, yeah, Mr. Cropsey, yes. Hole. Really? Even in the book it says removable discontinuity. Even in my notes. How come you guys are writing this down? It's all in my notes. Removable discontinuity. So if you ever have a removable discontinuity, you need to label it. So how do I label this? -2, comma what? Yeah, but Mr. Park, when I plug in -2, the denominator is 0. It's undefined. Yeah, you plug it in this one. You know why? Why do you plug it in this one? Because that's the graph that you drew. So that's why. Plug in -2 here. Can we do it? Please give me strength. Plug in -2. -4 over 9. So -4/9. So here. Now I get full credit, Mr. Park. No, I would have to give you -1. You know why? Because look at this. Look at the coordinates of these removable discontinuities. Look, if this is -1, would you say that's -4/9? Not even my dog would accept that. -4/9 would be a little further. Look, here's half. It's going to be a little less than half. It'll be up here. Which means now you have to revise your graph. So now it's going to look like this. There you go. Now you get full credit. So that removable discontinuity, you gotta put it like very near where it should be now. Sometimes you gotta revise your graph. Okay, so from now on, do not call it a hole, a puka, a ghost point, or Mr. Rubash. You guys just have no name for it, right? Right after this class, I'm gonna go down to this class and ask them, what do you call it? You guys don't even remember the word hole, puka, or whatever? How about RD, removable discontinuity? RD, Mr. Rubash loves them like short names. Okay, one more and we're done. So, what if I give you the graph and you have to write the equation? Now, you're not going to have to do that in tonight's homework, but tomorrow night's homework, you will. So let's just get a head start. this then. Okay, this like, you know what, I don't like that. I'm not sure if we can even do this, but we'll try. Okay, how should I start? Y equal, don't forget the y equal, some of you still don't put that, huh? Otherwise it's not a graph. Some of you are thinking, well, what's the difference if I put 0 there? Okay, well, let me ask you this. How do you graph this? Come on, you guys just took the PSAT, come on. The x-intercepts are 1 and 2. This is a parabola opening upward, so it's kind of like this, like that, right? How do you graph this? Is it the same graph? No, what is it? There, that's the graph. Because what makes this equation true? X equal 1 or x equal 2, right? What's the graph of x equal 1? Vertical line. What's the graph of x equal 2? Vertical line. What does or mean? The union of the twos. And that's, see, it's like two, that's why you need y equal. You don't put 0 equal. Okay, anyway, how do I start this thing? Of course, when I give you this problem, though, I'm going to graph it on my calculator so it's more accurate, because right now I'm not really sure exactly what's going to happen. Okay, well, what do I need? I see an x-intercept of 3, so what? You need x minus 3 on the top. I see a vertical asymptote of x equal 2. So don't you need x minus 2 on the bottom? Oh, okay, so that's it. I got it then. No, because what about the horizontal asymptote? What is the horizontal asymptote? Y equal 3. Now, how do you get a horizontal asymptote of y equal 3? If the coefficient, if the degree of the top and the bottom are the same, you got to look at the ratio of the coefficients. So therefore, there should be a number here. 3. Now, does that work? Well, what would the y-intercept be? 9 halves, 4.5. So 3, 4. Right, that's pretty close. It came out pretty close. 4.5. So yeah, that's what it would be. Of course, it's not going to be this simple though. All right, so I think we can graph. So tonight's homework, all you're doing is graphing rational functions now. I would like you to just, like, 1 minute a problem. Okay, we're not drawing a masterpiece here. We just want to draw the graph so that when we get to calculus, we can solve the problem. Here, let me show you. Here, you guys give me one, and I'll show you what I want you to do. I don't want you to make masterpiece, I just want a sketch. Okay, somebody give me an equation. Here, let's do something like this then. Okay, go.
X minus 1. X plus 3.
Good stuff, Mr. Park. X and
X minus 7.
x minus what?
7.
7. Oh, daring of you. Okay, so look, x-intercept is 1, -3. Y-intercept will be -1 times 3 times 2 over -7, so that's 3/14. Vertical asymptote, x equals -2, x equals 7, 1, 2, 3, 4, 5, 6, 7. I wouldn't give a number that big, and the horizontal asymptote would be y equal 1. And so we know the graphical, no, it's going to be down here because we have an x-intercept there, and we have all odd powers, so it's going to go like this, and then it's going to go through because of the odd power, and then odd power again. Woo! There you go. So you got to keep looking at the powers, whether it goes through or bounces off the x-intercept. You look at these powers if it goes the same way or the opposite way around the vertical asymptotes. It's not difficult. And you can see that this graph is going to cross right there, yeah? Now, you don't have to do this. I'm just going to ask you this on the next quiz. Where does the graph cross the horizontal asymptote? Well, what's the equation of the horizontal asymptote? Y equal 1. So So how do I figure out where these two graphs intersect?
Plug in 1 for 1.
Substitution. So 1 equals there, x squared plus 2x minus 3. Let's multiply it out. X squared minus 5x minus 14, cross multiply. 7x is equal to negative 11. X equals negative 11 sevenths. See, so this has got to revise the graph. Negative 11 sevenths is over here, yeah? So it's got to look like this. You know, if you wanted to make it super accurate. Anyway, it's not that difficult. This is probably, yeah, it's probably the easiest chapter of the second quarter. Because we're kind of in between quarters here. All right, we are done. What time is this class at? 12, yeah? So we got 5 more minutes. Oh, that lesson took longer than expected. Yeah, we can just go to our next class. Okay, here, I'll just tell you, tomorrow's quiz got 2-word problems. Put your mind at ease. So of the 3, you're gonna have 2 of them. Oh darn, it's on the video.